This episode of CppCast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/CppCast. Episode 106 of CppCast with guest Charley Bay, recorded June 21st, 2017. In this episode, we talk about a new online compiler tool. Then we talk to Charley Bay from F5 Networks. We talk to Charley about system error and the boost outcome review. Welcome to episode 106 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Doing good, Rob. How are you doing?
I'm doing pretty good. You all ready for the Chicago event?
Mostly.
Mostly?
Still getting ready, yeah.
It's a few weeks away now, right?
Yeah, I've got plenty of time. It's July 12th is the first day.
Okay, cool. And no real news with me. I'm just, starting to enjoy the summer, although we're getting a lot of storms out here.
Oh, I wish we were getting storms. It's like 96 today.
Oh, that's rough. Anyway, at the top of every episode, I'd like to read a piece of feedback. This week, we got a comment based on our discussion last week in the feedback where we're talking about the website. Vipul wrote in, open source C++ web frameworks, and he's got a link to Wikipedia here. Interviewing their contributors might lead the podcast to a better CMS solution than Node, NPM, and Sass. You guys beat me to half unconsciousness in the first 5 minutes of this last episode with all of those missile IDs. Vipul, I apologize for the Node and NPM discussion last week. I promise it's not going to be a frequent topic of discussion. But the website is fully fixed now, which is good, including the mobile site. I got that resolved.
Despite the fact that you're not a web developer.
Despite the fact that I'm not a web developer. I struggled through it. I did take a look at this Wikipedia page, which is a comparison of not all, but lots of different web frameworks, and it's broken up by programming language. So it does have 4 entries for C++. We've talked about Poco before, although I don't remember discussing it as a web framework, but I guess it does have an HTTP library as part of it. I quickly looked into some of these other ones, CPP, CMS, TNTNet, and WT, which I think is supposed to be kind of like a web Qt. So some of them looked interesting. It's just not necessarily what we need for CppCast, because we don't necessarily care about high performance or being able to run on embedded devices, which is what some of these are kind of meant for. We just want a simple web site that doesn't take too much for us to run, right?
Yeah,
Jason?
so it just compiles it and posts every time we post something new, right? I mean, it needs to be as simple as straight as possible.
Yeah, if someone made a C++ static website generator that ran off Markdown files, I would switch in a heartbeat. But
there might be one out there. I know I've had conversations with people about this kind of thing, but I don't know what the status is.
Yeah, we definitely don't want to rewrite everything in C++, though. But if we could use a C++ tool, that'd be great. Anyway, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Charley Bay. Charley is a software developer at F5 Networks with 25 plus years of experience in large-scale and distributed systems for low-latency C and C++. Charley, welcome to the show.
Hello, good to be here.
Hey, all right, Charley, 25 years of C and C++ experience, that's pretty good swath of experience there.
Yeah, well, back in the late 80s, it was a lot of C. C++ was only just getting started, right? So then in the early 90s, it was sort of, hey, there's this C++ thing, and it's got destructors, and it's deterministic, and we should play with that. And so I've always kind of been a bare metal hardware guy. I did a lot of embedded biomedical kind of stuff, and, we turned our own board, so it was a lot of low-level C stuff, but C++ ended up being really good for a lot of those patterns.
So, did you start using C++ then in the early 90s?
Yeah, in the early 90s.
Wow. And production code?
In production code. It was, back then there was, it was a lot richer. It was a lot more diverse environment, right? Because portability was kind of an issue. You had the segmented memory models. I mean, you and Godbolt, and, a lot of people have talked about the good old days, but, frankly, it's not good to revisit some of that stuff. Just let it go. I remember it was really interesting back when Microsoft's 03 compiler started to usurp the Borland version 5 compiler, which is a great compiler. Borland was doing awesome. And, all of a sudden these new tool chains started showing up, and, they've just gotten better ever since. Back then, it was often, hey, my code's right, the compiler's wrong. And you were right a lot of the time. Now it's kind of the opposite. Your code's wrong. It's almost always your code's wrong now. I mean, right. there are compiler errors, but, that bites such a small percentage of the real world.
Yeah, they tend to be quite esoteric, I think.
Yeah. Yeah, so I think that revisiting stuff back in that day, like even, shortly prior to that, where you manually did your linking by hand. You don't trust these linkers; those are crazy. You would do that by hand. Well, you don't really want to go back to those days. I mean, there's no good stuff to talk about back then. It's interesting, but don't.
So, but you've basically followed C++ for its entire commercial lifetime, pretty much.
Oh yeah. C-front. I never really used C-front, but the compilers, all of them, the commercial ones on up, I've played with all those. And, nowadays we have such really, really good options. I mean, the Clang GCC, the Intel ICC compiler, and then, Microsoft's compiler is really doing some awesome stuff. There's really, really great advances. And, now we mostly don't have to worry about these cross-platform portability problems. I mean, you can if you're bleeding edge and doing tweaky things, but, most developers, they've really got it good now. Write good code, make it clear, it will port, everything will be correct. And, it's funny because, you start working with some of these, new grads, and they're not exposed to some of this esoteric burn yourself on the stove stuff. And, I've got brain cells and neurons and pathways in my head that's devoted to this useless information. And I'm not sure that somebody starting out today should really know any of that stuff. It's not really relevant anymore.
But having gone through all this, I know some people loved the simplicity of Borland Turbo C++ with its 2E interface. Is there any piece of it that you say, I miss how X compiler back in 2003 worked, or something? Is there any piece?
Well, not really. Mostly it's I've been surprised at how my personal style has evolved, because, even though I've done it a long time, you think that, okay, well, you're done evolving. Well, no, not really. I mean, C++ 11, we all know that's all different, and lambdas is changing how we do things, and code constructs, the structured binding thing coming out with 17, that's going to change how we do things. But, it's even the simple stuff. I've changed, just in the last few years, my attitude on, placement of const and how to name things. And, there is some stuff that is still forcing you to evolve. But, back then, anything that you're sort of admiring, like the Edlin one-line editors, and, it's you can call that the glory days, but really it's just a waste of time, largely because I remember when Borland came out, I think Borland version 5 compiler, they were the first ones to come out with colored highlighting. And prior to that, you look at code on the screen, it's all one color. And then there's this colored highlighting, and I thought, well, that's really offensive to me, because real programmers should not need to see syntax highlighting on keywords. I mean, you should know that's a keyword. And, well, after a couple of years of that, I decided that was a good idea.
Yeah.
And, I think being open to change and evolving to best practice, it's surprising the little helps. Like right now, I tend to run I do a lot of Vim still, but when you're running an IDE and you have a spell checker, you think, well, you don't need a spell checker. This is code. It compiles, Well, a spell checker is pretty nice to have in code, comments or otherwise. So, even seemingly stupid, unrelated things like, a spell checker, it really ought to be part of the modern day coding environment. And, that was never even a dream back then. You'd never think about that.
Okay, Charlie. Well, we're going to talk about a couple news articles we have here, and then we'll start interviewing you about your work on the outcome library, system error, anything else that you find interesting, okay?
Great.
Okay, so this first article we have is that we talked about Beast again recently. They're going to go into a Boost review pretty soon, and they just announced, Vinny Falco, the author of Beast, that they made a full HTTP and WebSocket server framework based on Beast and Boost Asio, and that's now available for testing. So, we were just talking about those C++ web frameworks. Now, the Beast is another option there.
Yeah, and it seems the Reddit comments that we discussed last week were complaining basically like we need some higher level something, not just this intermediate level Beast thing. So, well,
he delivered.
Here's the full example. Yep.
Yeah.
Yeah, and I've been following Beast for a long time. The author's, very ambitious and active, and he's, very current with some of the latest language changes. And I'm a huge Beast fan. I think this is a great library. It's almost, it calls itself a framework, and that's where it starts to get interesting, right? Because anything that gets to the level of a framework, you're adopting, a paradigm and a use model, and other parts of your modules will have to adapt to this thing that's at the scale of a framework. So I'm a huge fan. I think we need more of this, but it's always a challenge when you use that word framework on any kind of submission.
Right.
So have you actually utilized Beast yourself yet?
I've not, but there have been several past projects where if it were available, I would have picked it, or it would have been a strong contender to be picked, because I think it's serving a real good niche, and I like the way he's approaching the problem. But, like everything else, the APIs are highly variable. I mean, it's like the Asio thing. Do you want to go Asio? Once you go the proactor model, that sort of modifies how you think about it. It structures all the code around your use of it. So you just have to adopt the metaphor he's presenting, which I think is actually a very good metaphor, but there's a lot of devil in the details on that kind of stuff.
And if you don't mind if I take a slight diversion, you work for F5 Networks. Have you guys adopted Asio internally? Is that something you can talk about at all?
We are a Boost user.
Okay.
I think that's public knowledge. And, Boost is a great library. We have a large legacy code base. There's new code bases too. So, yes, there is, like all large products. So for anybody who doesn't know, application delivery controllers, network traffic processing, that kind of stuff. We have a lot of code, and some of it is coupled to Boost. We have other languages too. And Asio, we are using it. Boost provides a lot of good stuff. Asio provides a lot of good stuff. So, for the low level data plane traffic, that's all handwritten, right? That's internal. Mm-hmm. But libraries like Boost just help you get work done. So yes, we're a user of Asio and Boost.
Are you looking forward to Asio potentially becoming part of the standard networking TS?
I am. It's Asio is, it's the networking TS, right? And it's kind of like the file system TS. They're kind of built in the same frame of mind for how you're going to start working with these, either callbacks or some kind of asynchronous problem space where you're trying to budget your design for handling delays, right? Some of these are very long delays. And I like them because they're solving in a clean way a problem that should be a solved problem. And we can't write this stuff out of the box for every new project. That's crazy. And yet at the same time, I think Robert Ramey's observations, on the general scale of, well, Asio's a big piece of work. It's a big work. And, is that a reusable library is kind of a separate question of, is that an industry convention or an industry framework that people tend to use. I think we're getting to a point where it is a little tricky, and I commend Robert Ramey for bringing up the thought, but it is a little bit tricky to figure out where does the standard end and where does the industry convention begin. And so networking is big. File system is big. As big as they are, I think they're incomplete, insufficient. You need more. And, well, that makes big even bigger. So, what are you going to do with that? That's a challenge. It's an industry challenge, really.
So this next thing we have is the Quick C++ benchmark. It's at quick-bench.com. And the interface looks really similar to Godbolt to me, where you can just put together a couple functions and quickly benchmark the output to do comparisons. And you use, I thought you were going to say, for different compilers, but it looks like currently it's just Clang.
And just Clang 3.8 at this exact moment, yeah.
Yeah.
I spent maybe more time than I should have this morning playing with it.
Yeah.
And I find it's great. I need now some sort of tool that'll let me look at the assembly output on Compiler Explorer, then click a button and have it automatically run the benchmarks for me. That would be just spectacular.
Well, whoever's making this, maybe he could get together with Matt Godbolt, do some collaboration where we could put the two tools together. It'd be nice.
That'd be great.
So Jason, question: when you ran it this morning, did you turn that show no-op bar on? Were you looking at the no-op measure? Because I think that's a great feature.
No, wait, I don't even see
it's
that.
at the bottom of the benchmark
bar.
graph. Yeah.
Oh, hey, that's neat. No, I didn't see that.
Okay, yeah, I really like that feature because it helps you normalize the overhead of the test from what you're actually testing.
Right.
So I found a surprisingly high amount of value in, do you have a no-op measurement? And, well, shit, this tool does. That's kind of cool.
Well, in this particular example is a very interesting one because it should all fall into small string optimization.
Mm-hmm.
That like the default example that comes up should fall into small string optimization, and Clang should be able to fold away like a shocking amount of it. Like these benchmarks, these timings must be really, really tiny that it's comparing here.
Yeah. Okay, so the next thing we have is Turing Tumble. Jason, you want to introduce this one from Kickstarter?
Yes, we've never promoted something like this on here before, and I'm not trying to say I'm promoting this Kickstarter, but I put it on here specifically because we have Charley as a guest today. And it was in one of your talk at CppNow 2016 that you mentioned Turing Trains, I believe.
Yes, yeah. I was not aware of this Kickstarter. It's a Turing Tumble. Looks like it's kind of like a kid's game. But yeah, it's a marble game. The marbles fall and you have gates and they go left and right. You can compute and count in binary. I thought it was really cool.
It looks like a lot of fun.
Yeah, it does. It's always painful when you have to build that much surface area to get 8 bits. But
right.
Yeah.
But, Turing Trains, kind of like little Lego things where they throw gates and you count and you do whatever. Well, shoot, that takes your whole living room floor. So, there's a trade-off to make somewhere.
Yeah. Can you describe the Turing Trains briefly for the people who are listening who did not watch your video?
Oh, right. So it's an old idea. It's not my idea, but
right.
People out of Legos have built, if you hop over to YouTube or anywhere, they've built all kinds of mechanical computers that basically, a ball goes by or a train goes by and the gate flips. And, well, you can count and you start building higher order logic off of that. And, well, you can do shifts and divides and multiply. You can do whatever you want. So everything the CPU can do, you can do basically with trains running around on the floor of your living room. It's just you have enough track and enough, toys to play with. And,
like really, really slow-moving electrons?
Yeah. Yeah, although debugging gets easier, but usually, kind of like bugs or, the bug physically crawled in there and shorted the circuit. Well, this is decatting or de-dogging if it's a Turing train on the floor of the living room. Because,
right.
You have all kinds of mechanical maintenance, so you get to be a hardware guy in addition to a software guy.
This reminds me, I once saw a YouTube video where someone had built a simple adding machine in Minecraft, but it was, gigantic in the scale of the world of Minecraft. But, you have kind of simple electrical circuit type things that you could light up with a torch or something like that. And using those, he built this giant adding machine that you could fly around and use in Minecraft. It's pretty cool.
I believe
I can see
Go ahead, Charlie.
Yeah, I can see a lot of value to anything in virtual space because real-world space is highly limiting.
Yeah.
I think they've taken those Minecraft things like all the way to the point of like 6502 emulators, like crazy.
I believe
craziness.
Yeah. But yeah, back to this Kickstarter. It's only got a week to go, but they're already well past their goal. So it looks like this thing will be built. And there's a little video you can watch to see how it works, and it looks pretty cool. And they're saying it's fun for adults too. It comes with like 50 different challenges that you can do using these this little marble game and these different little plastic kind of bit flips and things like that.
Yeah, they're already 6 times past their goal, so yeah, it'll be funded.
Yeah,
you should order one for your kids, Rob.
I might do that. Okay, so Charlie, I think it was 4 episodes ago that we had Niall Douglas on talking about Boost Outcome. During the time we were interviewing him, he was still going through the process. Do you want to tell us a little bit about how that went from your point of view? How many emails did he have to go through? What was kind of the final outcome of the outcome library?
Right, yes. Okay, well, the process is complete. So the Boost Outcome review, it is over. And, it's a Boost review, right? So the outcome library was a tremendously successful review according to the Boost guidelines, or according to the Boost community, what the Boost does. This is my first time as a review manager. I'm usually a lurker. I'm in the community. I go to BoostCon, but I'm not really a library author. I've not gone through that process, but I stumbled across the library. I thought it was really cool. I contacted the author and said, "Hey, do you have a review manager?" And I volunteered to take on that role. And, it's basically public service, right? I mean, usually when you're assigned community service, it's court ordered. In this case, I kind of volunteered to do it. But the library caught a lot of attention. It really hit a nerve. There were some 850 emails on the list that talked about the library. At the conclusion of the review, I read all those a second time because I had to prepare a review report on the conclusion. And there was a lot of discussion in a lot of tricky areas. And I thought it was fascinating and interesting largely because of the volume of deep and well-considered thought on appraising what's it trying to do and how and what are the missed opportunities and, what changes should be made. Is this thing is it Boost quality? So, at the end of it, there was a lot of support because it was my first time. There's a lot of support on, how does it work and the review wizards. I think the documentation is really very good. People can step into this role. But, largely what was not discussed in the review, even in the 850 emails, was the reason why I volunteered to be review manager, which is in the documentation. If you go through and you read through it, it talks about, Niall puts forward this idea of islands of exception in a sea of no except. And that really struck a nerve with me. That seemed like a very practical, manageable way to deal with error handling, exception handling at scale across big systems, across module boundaries, third-party modules. And, largely that conversation wasn't directly addressed in the review, but a lot of other things were, and substantive other things. So it was a great review because so much got covered. I think it hit a nerve because there's a need in the community. And, in this particular case of outcome, what he's trying to do, what the library really does, is he provides a mechanism where you can have this thing called result. And the result is either the value you wanted or an error saying why you didn't get that value. It's kind of like a generalized form of stood accepted, right? We have stood optional coming in C++ 17. You get your T or you get nothing. Well, stood accepted, it's not in C++ 17, it's probably in C++ 20. There was a lot of discussion on that tied into the outcome review, but it's a generalized version of optional where you either get the T you wanted or you got these other things. Maybe you could have several other things like, different kinds of errors, exceptions, whatever you want. And that was done because, if you can't have the T, well, why can't I have my T? Well, give me an error or give me an exception or give me something to tell me why I can't have my T. Because optional won't do that by itself. Well, outcome, the library, that's what it tries to do. I get my T or I get my error. and he has an outcome class. It's a T, or it's an error, or it's an exception. So, well, why do you have two? Because that was one of the questions on the list. Well, why do you have a result, which is T or error, or you have an outcome, which is T or error or exception? And then, insert 850 emails. Essentially, there's a lot of real-world system constraints that are imposed regarding static checking at compile time or checking at runtime. Whether or not undefined behavior is a good thing, because it can be a good thing because it's faster if I don't have to do extra work to give you a wide guarantee. I'll give you a narrow guarantee, and if you do a null pointer indirection, well, that's on you. So these trade-offs, when you deal with error handling is a very loaded problem. It tweaks a lot of people kind of in funny ways because you're talking about composition of APIs across third-party libraries, and that's a challenging, hard thing to do. Well, that's what Outcome tried to do. And the library, I think, did an excellent job at saying, look, here's a tangible implementation that is high quality, that will show you some multimodal operations where you can compose, specific to the constraints of your system, how you would like to handle exceptions, errors, or both. And in the end, I think the discussion was very productive. But in the end, of course, the library did get rejected for other reasons.
Well, do you want to go into why it was rejected?
Yeah. So okay, I am not an expert on being a review manager. I am very studied in this domain, which I think is an important and necessary requirement. And the Boost guidelines say it. You have to know the domain to be a review manager. I would have voted to accept the library. But I'm, in the role of review manager, there is discussion on a lot of topics. You weigh them and assess on the whole, is this going to be a viable good thing for the Boost distribution because we didn't miss opportunities, it makes sense, the implementation, the documentation, everything's up to quality of what's expected in Boost. Well, in this particular case, I think it harkens back to every now and then, not always, but every now and then, you have a fundamental problem. And some of the approaches tend to be fundamental approaches or libraries or solutions where you sort of rethink this is the new best practice for the industry. So for example, Asya and the TS networking, TS for C++, it's not in there. How many years has this been going on? There's been talk, and yet it's not in there. So is that a failure? Well, that's not a failure. It means we're still trying to figure out, the sharp corner cases. How are we supposed to think about this? What is the best way to compose and deal with networking in C++ code bases, especially in light of these new language features, which are changing how we compose our algorithms, how we establish our public APIs, and what is this vocabulary type, or even is there one to transfer state, error state or exception state, across third-party boundaries that were not designed to talk to each other. So this, I think, is what Outcome stepped into. It is that. It is at that scale, and that's why there was so much discussion. So the rejection largely is based on, we did have a couple of technical things that are important that were not at consensus at the end of the review. There were a couple other things that were, maybe dealing with the library. It was perceived as setting precedent to changes to the Boost distribution itself. There's some CMake stuff, and there was a dependency on a module that was external to Boost itself, and it had dual license, Apache 2 and DSL. There was enough coloring outside the lines that some of the reviewers were a bit. It challenged their ability to evaluate, well, am I evaluating a library, or am I evaluating a modification to the Boost distribution packaging and policies? And I think some of that cluttered it a little bit. So in the end, there wasn't enough community consensus for the libraries. It was rejected. But I would have, if I were a voter, I would have voted to accept. It's just that we had enough people with well-reasoned, substantive thought on, we probably do want some changes. And the author, Niall, he agreed. Yeah, there's some changes that he would like to do as a result of the feedback of the review process. The review process was highly constructive. There was a lot of information given on a lot of topics. And there was a bit of overlap with stood expected. It's not in the standard yet, but it's being proposed, and there's maybe some discussion about how that might evolve. There's a lot of talk about stood variant, and it's got that empty by exception kind of thing going on, which is a little funny. And so there was talk about, well, could we have a variant 2 that did not have that edge case, that corner case? So outcome, especially if it becomes a vocabulary type, it's kind of in the same area where, do you want this thing to work with wide contracts? Anybody can play with it and use it and they can't hurt themselves? Well, you're going to pay for that. Or do you want it with narrow contracts? And, you have to use it just right or everything explodes and everybody dies. And, you gotta kind of pick a direction. And one of the things that I think that the outcome library did that was really, really good is there was a very clear contrast in, this, I give credit to Niall for this, but he identified basically as single modal usage or multimodal usage. And that, almost always you want to do the single modal usage thing where, what's that? Well, here's my library, here's my API, and, this one canonical way, this is encouraged, this is understood, we can scale off this. That's a single modal thing. Well, every now and then you get this multimodal thing, and outcome was sort of forcibly pushed into this multimodal domain. And that was, according to the author, was because we had different user bases with different constraints. Some of them wanted to compile with or without exceptions, or with or without static runtime checking, and with or without narrow or wide, or other things dealing with runtime overhead. And what the outcome library did is, if you want all of that richness where you can insert your custom error type with different behavior and different runtime constraints, different compile time guarantees, if you want to compose that and set it up, compile it, propagate through the framework and out your public APIs, you can do that. But that does significantly complicate the design. And that's what the reviewers saw. They caught it and they called that out, saying, look, is this complication really necessary? Because what a lot of the reviewers are saying, which is very legitimate, is, look, I don't want a complicated design. I want something simple. I want like system error. System error is actually pretty simple. And the whole idea there is, look, I've got a thing. It stood, error code. And I can pass that from my API to your API, and that just works. It's a type array, simple way that we all have a common understanding of what is the error state. An outcome in a single modal design, kind of on a C++ standards track, perhaps evolving into something inserted into system error in the future, the header, system error in the future. Well, that would be cool because I have an error, an exception wrapper. You're using the same one. I don't have to recompile. We can just relink or, dynamically link at runtime. And, we're all using the same types. But if everybody can do their own thing, if everybody can compose according to their own system-specific limitations, well, you kind of give that up. So do you want a simple design, single modal standard track, or do you want a complicated design, very user configurable, very tied to your system-specific constraints? And, Niall was very clear. Low latency was a lot of what he was looking at. If you want to go low latency, it's kind of nice to have that power. And the outcome library basically was trying to give you that multimodal best of both worlds, but it's not going to give you the best of both worlds, really, because the single modal design, by definition, is you got 1, 2 types. They're simple. Everybody uses them, and you get what you get. So it's I think, a tremendously healthy thing for the C++ community to talk about this error handling, exception handling thing. And I think in general today, for whatever reason, we do not really have consensus where, our current libraries, our current idioms, our current practices, that's sufficient. It's good. We got it. We understand it. I don't believe that to be true. And outcome really tried to lance that windmill. And, it's a tough one. So coming out of it, though, actually, there's a lot of good things. I mean, there was enough discussion. There were some changes to, hey, we're going to make these modifications to the design. There is internal work in outcome. I think it's production ready today. I think people are using it today, and now could probably give you more more information about that. But some of these changes that are underway based on the feedback, they're good changes. I mean, you want ideally a review process to be a review process, and it was. And that means I see what you did, I see the domain you're trying to address. Does this address that domain? Were there other ways we could have done this that maybe would have been better? And okay, specifically what you did, are there any missed opportunities? You know, if I tweak this or fiddle with that, it'll scale better, it'll plug in with these other things better. You know, it handles these language features better. One of the things that I never really expected, I never thought about at the beginning of the review process that I learned along the way was, well, if you have a vocabulary type, you know, here's this thing, like std variant is one, or std optional would be another one, std expected, when it shows up, it'll be another one. Well, if it's a vocabulary type, you know, you tend to want to provide guidance to users regarding how do you want to iterate on these things? How do you want to establish a visitor pattern that can safely interrogate and rip out the state from the variant that's relevant? And you know, that's a design thing. You know, you have to decide that up front and lay out an API where that'll work. And some of the discussion with Outcome was specifically on that topic. You know, how are people going to use and scale with this thing? And based on those changes, there's some internal implementation details that are going to change, but probably some API changes too, and maybe a couple name changes. So from that standpoint, the review was very effective because the library author got good, actionable feedback that the library author believes will make the library better. So it's the Boost review. It's you know, it's sometimes like Clash the Titans, but you know, it's a pretty fantastic thing that you have all of this outstanding brain power dedicated to reviewing, you know, essentially what becomes world-class, tricky, and complex problems in the face of what is current best practice? What are we bringing out with language features? How are you supposed to use, you know, even the C++ language standard itself?
Right. So do you think once all of this feedback is taken into account and IL makes changes to it, that it has a chance of actually being accepted?
I do. And you know, this is kind of like the, you know, the networking TS. You can use Asya now, right? Whether it's part of Boost or not part of Boost, you can use it. Outcome you can use now, whether or not it's part of Boost. So, well, the networking TS would be better if it was maybe in the standard. Well, you know, maybe that's true. So, well, it's just a TS, right? So you can use a TS, even though it's not kind of not in the standard. So Outcome, you know, I think there is a question that we still have not answered, and I defer, you know, to the library authors in the future review, but do we want to go standards track or do we want to go to this multimodal user composable thing? Because they're probably a little bit in contrast with each other. So I am confident that the Outcome library will evolve, and it will go from a good library to an even better library. It may or may not make it into Boost. I think it probably would. With these changes in some of the other discussion, I think it would actually be accepted into Boost. But, you know, I got to fall back to Robert Ramey again a little bit in that the library as it is today, we concluded a review and it was rejected. And that does not mean it's a bad library. It doesn't mean it's not production quality. It means that the Boost community couldn't figure out quite how it fit in and whether or not it did reach that level of, I understand it, these idioms are good, and we are now recommending new best practice. We didn't really have that. Now, ideally, that's the bar we would reach. If it's a niche library, you know, maybe it's not a big deal. But this isn't one of those. It's more of a fundamental thing. So I think another Boost review, if it were to occur, it could be big and wild and contentious and back to narrow and wide contracts and all kinds of stuff, in part because the questions I think for this particular library we're trying to answer is, do we understand the idioms and are we experienced enough to make sensible recommendations about, yes, this is something that should be used, you know, in this way. You know, is that a niche thing? Is that a general thing? Is that a standard thing? And, you know, it's kind of hard to guess what's going to be in the next standard. And for the same reason, it's kind of hard to guess what the Boost community will see as this is a well understood, accepted practice where we're ready to endorse these idioms as okay. Because it is new idioms. This is somewhat novel that you can get a T or an error back, or a T or an error or an exception back. And, frankly, my selfish little interest is I would like more discussion about this sea of no except, what islands of exception in a sea of no except. I defer to Niall for putting that thought forward, but I think that really is the closest I have seen us come to unifying errors are not exceptions, they are different. Their composition patterns are similar. Sometimes they're trying to do overlapping things, but in our heads we have not separated them entirely, and therefore we don't really have a vocabulary to talk about them. So,
right.
I don't know. Maybe that vocabulary is resolved at the next review. I don't know.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/CppCast. So a moment ago, you mentioned system error a couple times, and you just gave a talk about that at CppNow. Do you want to tell us, what library developers or library users should know about system error? I know I'm asking you to summarize an hour and a half talk in a few minutes, but
No, that's fine. Actually, it's not hard to do. I can almost do it in a sentence. We'll get a couple sentences, but system error is the standard error code in the C++ specification, and we see it a lot in the file system and networking TSs. You'll see more of it. People don't know about it, I think in part because everybody hates error handling. It's just annoying. And frankly, it's a tricky problem. It starts messing with your APIs. And error handling as a rule is sort of a very contentious thing because it does reach deep. And, the talk kind of goes in a little bit why it might be contentious. But in essence, system error is a lightweight little baby thing. It's an int and a reference. So it's 16 bytes, essentially size of int plus size of pointer. And it gives you a type erased, platform-specific, non-lossy propagation of error state. And you should use it. You're going to get it back from standard APIs. You should propagate it to whomever you want. And maybe you'll do branching logic or conditional processing based on the error you get back. But effectively, a library developer, if he wants to make one, you can define your own. They're called error categories. You derive from error category. It's a virtual base. And you do some stuff, and it's not hard. You can do it in 15 minutes. And basically what you're doing is you're saying, here's my set of enums. They correspond with these strings. These are my errors. That's it. Done. And now you can create these error codes just from the enum. It's implicitly created, and pass it back to somebody else. And they can catch that, get your enum, get the string version, start doing if statements based on what happened. Could I not open the file because I don't have permission? Whatever it is, and process on it. So, everybody I think generally has written their own error class for various reasons, and you don't have to replace that with this. You can, but this is really a great adapter. You can shove anything into an error code. So if you have C errors from C libraries, you can put those in error code. That's not hard. The libraries are starting to give them to you, but as library author, you can make them. But essentially, you're just giving the users the ability to handle enumerated failures for conditional processing. That's it. They're light, they're simple. And the talk is long largely because I try to go into all the very complicated reasons for why system error is so simple. And it is simple. I think it can be evolved more simply. I think there's improvements we can make to it. But as it stands, it's not a big header. I mean, error code, you got it. You're working with enums, you're none. It's kind of simple.
Having seen the talk twice now, I walk away going, okay, I know I need to do something with this knowledge I now have. But how do I roll this into existing design, or do I just need to start a new design from scratch where I'm thinking about error codes? Do you have any advice?
Yes, right. Putting lots of little asterisks after it. Every design is going to be different, right? And you're going to, error code is not trying to solve so many things that people also need solved, and I think it's important to separate, what it's going to give you from what it's not. So, for example, it's not going to give you syslog or routing or interprocess anything. It's just an enum. It's a little enum bundle that's somehow magically associated with a string. And if you say, okay, well, it's an enum that I can give to my users, well, that's conceptually pretty simple. So, as a user, you'll just use it and test against enums. That's hard. You don't have to do any work. As a library author or as a system implementer, there's probably two levels you're going to go at. One is, look, I'm doing this library, does this thing, and here are all the things that can go wrong. You asked for this, I'm going to say no, but I'm going to tell you why. And I've broken out a bunch of enums. If you're able to lay out an enum with these are the cases that may fail, and you might want to tie that to a descriptive string about what that enum means. That implementation, rather than give the user an enum back, you give them an error code back. That's it. So if you're doing functions where you're returning Booleans for true, false, for succeed or not succeed, I'd highly recommend you jump immediately to an enum because they're more open-ended and extensible. But if you jump to an enum, it's very little work to jump all the way to error code. So I would just go that far. So what is error code? Well, it's like a glorified enum. That's all. But it's a type-safe enum that preserves system-specific state. So there's this type erasure mechanism going on in there where, I've got an enum, it's my library's enum, and I publish that, and the user gets an error code, and they say, hey, is this error code looking a lot like that enum coming from that library? That's all the user needs to know, and that's not hard to do. So really using error code is the act of using enums. However, the implementation of it gives you a lot more power. And once you start going down that road of power, it starts to be, well, I've got this bucket of enums for kind of network problems, and I got another bucket of enums for kind of my system's fluidic subsystem kind of stuff, or another bucket of enums for, well, we call those categories. I think the proper name is domains. I might have 3 or 4 domains. Well, probably most any application you have 4, 5, 7 domains. You can have one domain if you want, but probably there's several. Well, error code is a better enum in that it gives you this thing called error code that is type erased to where all of your 5 or 6 or 12 domains, they're all in there. I mean, you can pass any one of those. So you don't have to touch your function signature where this function might return this type of enum, but that other function will return another enum. Well, what if I have a function that might return either of those enums? Well, you're screwed, right? I need to pick an enum. Right. Well, no. Error code handles that. It erases that. So you get both of those enums out of that function. So any function that may have problems that ultimately rolls up several domains, well, you don't have to pick one master enum category. And that really is the design of system error. You can't really do a master enum category. We tried, it failed, and that's why we have the design of system error itself. I don't want one master enum. I want a bunch of little domains. Oh, by the way, this function might actively tell you about a couple 3 domains might have problems.
Is there
now, go ahead.
Any gotchas or limitations?
There are. The biggest gotcha is instance-specific payload. And if you go into it deeply, the land of structured logging kind of gets into this where, I don't want to just say, enum couldn't open the file. Well, which file? Well, I know that right now. It's this file. So wouldn't it be cool if error code would allow me to stick a little payload in there for the file name that you tried but failed to open is this file name?
Right.
Error code itself does not have payload. Now, outcome, what Niall's library did, he did put payload in his. And that was interesting. Now, and in the talk, I also talk about, I figured out how to get payload in there. You just don't put it in the error code. You put it in the error category. So instance-specific error message payload, a lot of people want that. You're going to pay for it, right? It's state that you have to pass around. But if you really want that, error code does not have that out of the box. You have to a little bit color out of the lines.
Okay.
And the last little thing, which is sort of the second part of you said before, hey, I want to get started. Well, okay, if you have a function that returns a bool, don't do that. Return an enum. If you have a function that returns an enum, but, it could actually return one of a couple of enums because a couple of things might go wrong. A couple of domains might be violated for some reason. Oh, okay, go to error code. For most everybody, stop there. That's good enough. There is this other deep end of the pool, and I talk about it in the talk, and it's basically the semantic cross-domain mapping. And this is not an error code problem. This is a module API design problem. This is a way of saying, I know at the lowest level that I don't have permissions, or the hard drive's full, or the network timed out, or something happened. I know at that level what happened. But that's not what the user wants. The user wants something higher level. The user wants to say, I failed to do this thing that you really wanted to do, and maybe I give you some guidelines about, fix this, close that, or, how to get yourself out of trouble.
Right.
Well, that semantic mapping, that cross-domain mapping, is I want to somehow map from a very low level of a whole bunch of things might have gone wrong, but I want to map that to this higher level thing, which is, yeah, your transaction failed, sorry. But, maybe there's some detail there that I want to preserve, but sometimes you want to throw that detail away. You want a lossy transform. And system error does have a design mechanism to do that lossy transform. You're essentially, the parallel would be if you write code to where you invoke a function, you catch an exception, and you don't rethrow that exception, you throw a different type, a different exception type. That would be an example of a cross-domain mapping. I'm not throwing what I caught, I'm throwing something else. Okay, well, you've mapped from one domain to another. Good for you. Well, system error has a mechanism internally, the way you derive from error category, to allow you to do that. So I have one of these enums, and I'm going to identify that, and I will intentionally, in a lossy way, convert and map over to this other enum. And that cross-domain mapping, that's a harder, it's a trickier implementation inside the error category that you write for your domain, for your error, but it's because you're a library author and you've decided, look, for these cases, I want to map to this. For those cases, I want to map to that. And they might be overlapping. And that's a design consideration. So it's not an error code problem, it's a design problem. How would I like to intentionally throw away state, do a lossy discard to provide better actionable context to the user? Because ultimately the highest level, at some point you get high enough where I don't want to hear anything about the subtle nuances of some little database. I just need to know transaction failed. And I know that lots of things may have contributed to that. Maybe you can provide me guidance, but I needed that cross-domain mapping to be provided by your higher level API. So that's really tricky, hard work. It's heavy lift, design lift by the library author. System error is not that complicated. It gives you a mechanism to do it. The hard part is deciding how you would like to do that semantic mapping. How many domains should exist? At what level? What mappings do you want? Well, system error is just a mechanism. It's not going to help you with any of that.
You've given a couple talks now on CPU architecture and how lots of magical things happen basically behind the scenes for us, and we should be okay with that. So I'm just kind of curious, what's your interest in this stuff?
Oh, well, I like to know how things work. And a lot of times, there's enough going on in software. We're focused on that. You have enough details there that you can keep yourself busy. And, how many minutes in the day do you have left over? But there is this growing concern, for, hardware at all levels, mobile or heavy lifting, it doesn't matter, that increasingly we are designing software abstractions that drifted a bit, moved away from how the hardware actually works. And we can, without trouble, invent leaky abstractions to where our software system, in theory, is correct, and it is. It just kind of doesn't work. It's either too slow, or it has edge cases that are a little surprising. They're correct, but they're surprising. So I like looking into the low-level details, and in part, so there's two things, right? I like understanding how it works because I do think it informs your design. It gives you more options, more degrees of freedom for how to think of the problem. But, there's kind of the second thing, which is I can't talk about what I really think about a lot of programming practices because my ideas are too out there, probably. But in the hardware land, it's a little easier because there's not a lot of debate on how the CPU works. I mean, you can have different opinions on what is important and what you think about how it works and maybe even how to leverage it. But how it works is how it works. So, the talks I've been doing in part because it's interesting, it's useful, it's helpful, and it's constructive. And at some future point when everybody agrees that we all have a view of how the hardware works, and I think the cache line, if you don't really know what it is, you're going to kind of have to get into it at some point. And, at some point when everybody kind of knows what the cache line is, then we will probably disagree violently on what the hardware does and what the meaning of it is, because it kind of gets into, the essence of software and the nature of processing. And, the CPU, all it's doing is moving bits. That's it. What's it do? It moves bits. Well, no, it's doing more. No, it's not. It's moving bits. There are data objects in there, and we might do some instruction decoding, and we've got a lot of filtering going on because of branching and directions, and we throw stuff out, and it's really just moving bits. And when you start to get into processing, well, we have biological computers now, and we're doing all kinds of quantum effect processing kind of stuff, and chemical computing now, like little tubes of stuff that are generating pi or real mathematical answers. And well, those aren't CPUs. I mean, they're not sitting on little wires where you charge it and there's this electromagnetic wavefront pulse that runs down the wire. I mean, they're doing biology and they're computing stuff. Well, now you get into the human brain and how's that work. And, I find that stuff fascinating because some of what we do in software, I think, scales and is a good model, provides a good framework to solve problems. But some of what we do, introducing incorrect abstractions, absolutely take us in the wrong direction. And, that's kind of the controversial stuff. So I can't really have talks about that because it's just nutty. It's out there.
Well, you mentioned the phrase you used, leaky abstractions, and I think I've read that phrase somewhere before, but I just cannot recall the context. Is that?
Yes. Yeah. So leaky abstractions, and the idea is, hey, I have a tape drive, and well, I know what a tape drive is. It's like a tape, and you can go forward and backwards, but basically, I mean, it's basically a buffered sequential device. Mm-hmm. And okay, well. All right, so I'll make an abstraction. It's a buffered sequential device, and I apply it to this physical artifact that is the tape drive. Cool, we're done. Well, but the tape drive, it can seek backwards, and it can seek forwards, too. So I could, if I wanted, I could present it with a non-buffered random access API. I could abstract a non-buffered random access interface to the tape drive. It'll be slow, but it'll work. It'll work absolutely fine. Mm-hmm. Okay, well, at some point, if I do that, the impedance mismatch between my design decision of non-buffered random access to the tape, my latencies are awful, right? It works, but at some point, there is enough leakage of real world, the tape under the hood is being thrashed back and forth, and I can't get anything done within a year on my computer, that my abstraction just kind of fails. So reality under the hood leaked up through my abstraction, and my abstraction fails. And, I'd say, one of the good examples today would be, hey, I want to do this low latency distributed system. Well, that's cool. There's this internet thing. I hear it's going to be big soon. And so if I want to do low latency distributed stuff, well, that means I probably want to cache, and I'm going to probably need local storage because I need low latency. I want to go fast. No. A hard drive is a tape that runs fast. And mechanical sympathy and some other people have talked about this, but essentially a hard drive is a fast tape. It is a tape. If you want to go fast, you go to the network. You would never, ever, ever in a low latency asynchronous system go to the drive. I mean, it's just too slow. You go to the network. Oh, what do you want? Well, I want random access, non-buffered stuff. Oh, wow. Well, the network abstraction is actually a way better abstraction for random access non-buffered. Your hard drive really is a sequential access buffered thing. It's a tape. And so, as you start looking at how the world actually works and then the abstractions you want to put on top of them, if your abstractions are just insane, I mean, they're correct, right? You can implement a random access tape drive. It's just going to cost you. And it's cost that serves no purpose. So, it's kind of like, we're programmers and, I bought this goldfish and I brought it home and it's a lovely goldfish and I love my goldfish and, the poor thing is starving to death because I don't know how to feed that guy. And, it's a beautiful goldfish and it hasn't died yet. So, we can call that success, but, we're all bringing home these CPUs, these goldfishes, and we're starving them to death and they're in the bowl and they're choking saying, give me bits. And our designs just won't do it. And it's like we're the meanest people ever. So, yeah, I think when you learn a little bit more about what your goldfish needs and its dietary requirements, feeding your goldfish won't be such a problem. But, goldfish are people too, and there are a lot of goldfish out there that are suffering daily. And, I'm on a mission to make sure no goldfishes die. Well, they're going to die, but sorry.
Needless to say, you think it's important for C++ programmers to have some understanding of their hardware.
Yes, largely because we have control of that, right? C++ and then C, we directly address the instruction set architecture, which is the interface to the hardware itself. So the chip vendors, they give us the ISA, the instruction set architecture, and they say, this is how you address my hardware. And they give us all the guidelines and everything they can to let it be productive. And, well, our language has that, C, C++, but, Python or some of these higher level languages, they don't have a prayer of that. I mean, they might be able to do some really good implementations in JVMs or JITting or whatever to make it better, but they fundamentally cannot implement abstractions that model how the hardware actually needs to be fed. We can, and as a result, like anything else, you don't have to pick up all the money laying on the table. You don't have to, but if it's easy enough, it might be good to do that. And, our language gives us the tools. And, frankly, that's really what C++ 11 and then 14 and then 17, it's really what they're doing. If you go in there and you start looking at all that stuff, and, R-value references and lambdas and whatever, there's a bunch of stuff, and it's good stuff. It's stuff I want. It's stuff I really want to use. But almost all of that stuff is ways for the program to articulate to the compiler, this is what I'm trying to do. And giving the compiler the discretion and the power to generate efficient assembler to let the hardware do its job. So, frankly, we, in the modern C++ era, we are talking very intimately to the compiler, whispering sweet nothings, providing hints. The compiler will have to figure out how to map it to some specific target architecture and make trade-offs, and they're very good at doing that, and they're getting better. But largely, our act of software professional engineering is the act of, frankly, talking to the compiler. It's weird because in the olden days, it was talking to other programmers for portable assembly. Well, not anymore. I mean, with the new language features, that's not it. It's hints for the compiler. That's it.
Charley, it's been great having you on the show today. Where can people find you online?
My email address is on if you go to the BoostCon or the CppCon talks, I have my email address on the front of the talks, but I don't really have Twitter or anything because, I haven't figured out this internet thing yet.
It's just a fad anyway.
It'll fade out.
Okay, well, it's been great having you on today.
Hey, thanks a lot. It's been great.
Thanks for joining us, yeah.
Take care.
Okay. Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in, Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@CppCast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.